Good afternoon and welcome to today's Expedition 5 overview briefing. On my right is Diane Murphy, Expedition 5 Increment Manager. Next to her is Dr. Vic Cooley, Expedition 5 Increment Scientist. And on his right is Tina Milton, Expedition 5 Payloads Operation Director from the Marshall Space Flight Center. Diane?
Welcome to the beginning of Increment 5. Increment 5 is that time period at which the 5th expedition crew will be on board the International Space Station. I believe you will meet the Expedition 5 crew a little later this afternoon, but the crew is composed of a commander, Valerie Corzine, who has had many flights on orbit, and particularly the Mir, and there are two rookies, Peggy Whitson and Sergei Trezhev. The start of Increment 5 it begins with the arrival of this Expedition 5 crew with STS-111, or the UF2 flight, when it docks, and it will continue on then to the their departure when the Expedition 6 crew arrives in STS-113, or the 11A flight in mid-October. The time period that is currently planned for them to be on board now is 135 days. There's a handout that you all should have that shows the timeline of the major events that will occur during this increment. There are 3 vehicles that will arrive after the crew is on board. There's a shuttle flight, STS-112, or 9A, that will arrive in mid-August, and it will continue the expansion of the International Space Station with the delivery and installation of the S-1 truss. In addition, we have 2 progress flights that will be coming up. The first one is referred to as 8P, and it will arrive in late June after its launch on June 26th. It primarily will contain the remainder of the Expedition 5 provisions and the hardware and utilization that the Russians may be sending up that will be needed during Increment 5. The other progress, 9P, will launch on September 10th, and its primary cargo will be provisions and hardware and items that will be used during Increment 6. During the UF2 stage, the UF2 stage is that time period from the undocking of STS-111 or UF2 until the docking of STS-112 or 9A. That time period in there that the crew's on board is referred to as the UF2 stage. The Russians have planned 2 spacewalks using their Orlan suits, and they'll be taking these walks out of the spacewalks out of the pier or their docking compartment. The first spacewalk, referred to as EVA7, will be performed by Commander Valerie Corzine and Peggy Whitson. There are a couple things that they will be doing that are more significant on this spacewalk. The first one is the final installation of the service module debris panels, or known as FMVP. I believe a little earlier you heard some about these debris panels that were being taken up on STS-111 or UF2. We're going to show you an animation here that some Russian programmers put together and very graciously provided to us via Energia so that you all could see it today. So if we start rolling that. First of all, you see the 6 panels known as the FMVP that are stacked together and wire tied, and they're launched in this configuration for security, and it also allows them for easy translation across the International Space Station. This is the animation I was referring to. You've got Valerie Corzine, who is standing at the base of the Russian boom, or Strela as they call it. It's attached at the pier docking compartment. Peggy Whitson will be at the end of the boom. He'll extend it out and then translate her over to where the debris panels have been left behind from UF2. Afterwards, then Corzine will translate down the boom, the Strela boom, to that location. Now, this location is a temporary location that these debris panels were placed during the STS-111 flight. They are still stacked in the configurations that you just saw. After they take them from that and attach them to the Strela boom, then Corzine translates back to the base and then rotates Peggy and the debris panels at the end of the boom and rotates it around to its final location, which is on the Zvezda. The actual motion that you're seeing here is significantly faster than the real event. It's been sped up for our purposes. Then once they get to the final location of the Zvezda, again, Corzine translates along the boom to the Zvezda with to meet Peggy Whitson there so they can do the final installation. The next piece is a training film that was taken while the crew was doing their training in Star City, in the Hydra Lab in Star City, Russia. If you roll that. You can see the 6 debris panels here. They have now been removed from the Strela boom, and they're going to be temporarily placed all in a stack. And then Peggy Whitson will one by one remove these panels and hand them off to Valerie Corzine to be placed. Now these panels, there's 6 of them, and each of them have their own specific location, and we'll take them off and put them in their identified location, and they're basically around the window that you'll see around Zvezda. Here you can see Corzine doing the installation. He's attaching some bolts with some brackets around the handrails that will secure each of the debris panels. There's some additional debris panels that will be coming up on later flights downstream. In addition to these activities, there is another activity that the crew will be performing, and that is the retrieval of a Kromka panel. It's a contamination experiment that the Russians had, and they will be bringing it back in and replacing it with another panel that was brought up on a progress. The second spacewalk, known as EVA8, will be performed by, again, Valerie Corzine, and this time it will be Sergei Trezhev will be joining him. They've got several significant activities. One of the most significant one is the replacement of a liquid flow control valve panel on Zarya. And we'll roll the training session for that. The crew has just emerged out of the pier, excuse me, with the unit. The unit is actually inside this container known as a pig, and they're having to open it up and remove this liquid flow control valve pump. It's been tightened down for the launch configuration. This panel is part of the cooling system that's involved in this Zvezda. One of the units has reached its lifetime, and they're going to be replacing it during this stage. As you see, they're pulling it out. It's got some handrails that allow for easy access to it. There are 2 of these on the Zvezda, and then there are 2 on the Zarya. The one we're replacing, the Zarya, you can see it here. It's going down into this cavity well that you can see down here. And again, they've got the handrails that make it easy for them to hang on to, and they'll put it down into the pit and then bolt it down. And there was one sitting off to the side that they will return back into the container that was there. In addition to this activity, there is another experiment that they will be working on, and that's a NASA experiment known as Impact Seeds. There are 3 panels out there right now. They'll fold one up for return to bring back in, and we'll eventually bring it down to the Earth for further analysis. The other 2 will be relocated to collect additional data. In addition, there is 2 remainder amateur radio or ham antennas that will be deployed during one of these 2 EVAs. There were 4 of them that were taken up during UF1 flight. 2 of them were deployed or installed during the increment 4, and the other 2 will be done during the spacewalks in increment 5. Some additional activities that will occur during this increment includes the replacement of the carbon dioxide removal system known as CEDRA that's in Destiny or the U.S. lab, and we'll be taking it up. The hardware is going up on STS-111 or UF2. We'll do the change out during the stage and then bring down the previous CEDRA on 9A or STS-112. We'll also be doing some check out of the newly arrived MBS that's being attached to the MT and doing a walk over of the robotic arm or Canadarm that's on the MBS to get it ready for flight STS-112 or 9A. And then other than that, we have our normal maintenance activities and our utilization. From a U.S. perspective, we have about 210 hours of U.S. experiments that we'll be doing during this increment. And Vic Cooley is here to give you more information on what those experiments are.
Thank you, Diane. I'd like to provide a brief overview of the science program that we have planned for this increment or expedition. Along with the expedition crew, the UF2 flight will deliver 680 kilograms of science payloads and 1,160 kilograms of science support hardware, including 2 new science racks. This hardware, along with the crew and the ground support teams, and a plan for 233 hours of in-flight crew time to support those investigations, will provide for a program of 25 investigations on Expedition 5. It should also be pointed out that returning to Earth on the UF2 flight, in addition to the Expedition 4 crew, will be 600 kilograms of completed science payloads. I now have a video, so start that video please. Recall that the US lab module is a cylinder 15 by 40 feet long. The lab module is populated with racks which are secured along 4 sides of the module. The Human Research Facility, or HRF rack, is one such rack, and there are 4 other racks known as express racks. 2 new science racks will be transferred this flight, the Microgravity Science Glove Box, or MSG, and Express Rack number 3, giving a science complement of 7 racks. The glove box rack, shown on the right, is the same size as the other science racks. The upper half of the MSG is a sealed work volume with built-in gloves for accessing the work volume. The MSG was designed and built in a collaborative effort between the European Space Agency and NASA. Next slide, please. The Crew Earth Observations investigation will continue during Expedition 5. Crew members are able to produce higher than expected resolution photographs with high magnification lenses by learning how to compensate for the relative motion of the Earth below. This discovery has resulted in one of the first ISS Science Journal publications and is opening new possibilities for ISS to study changes that are occurring in very small features on the Earth's surface. The materials on ISS experiment, or MISSE, continues during Expedition 5. The MISSE passive experiment containers, or PECs, were clamped to the exterior of the ISS in August of 2001. Each PEC contains hundreds of samples ranging from lubricants to paints and solar cell technologies. These PECs will return to Earth in January of 2003. 10 human life science investigations will be conducted using the Expedition 5 crew as subjects. The sub-regional bone investigation continues from Expedition 4 and focuses on the pre- and post-flight measures of a crew member's bone density. Improved bone loss measurement techniques leading to accurate evaluations of various on-orbit measures to counter bone loss may reveal mechanisms which can be applied to reduce osteoporosis on Earth. The Xenon-1 investigation also continues from Expedition 4. Orthostatic intolerance, which is typically encountered by an astronaut returning to Earth, may interfere with his abilities to perform re-entry and landing duties. Countermeasures developed as a result of this experiment may also be helpful to millions of people on Earth, particularly the elderly, who suffer from circulatory problems and diseases that can cause low blood pressure, dizziness, and fainting. Biopsy is a new ISS investigation. Using pre- and post-flight calf muscle biopsy samples, this experiment will determine the functional and structural change in limb skeletal muscle, establish change mechanisms, and calculate the calf muscle change that would be experienced by a crew member traveling to Mars and back. 2 EVA-related investigations continue on Expedition 5. The Extravehicular Activity Radiation Monitoring, or EVARM experiment, will use miniature dosimeters to measure radiation received by a spacewalking astronaut inside his spacesuit. 3 1-inch by 3-inch dosimeters, shown in the upper left, are badges and are worn by each astronaut during EVA. EVARM is the first measurement of radiation dose received by a crew member during EVA. The effects of EVA and long-term exposure to microgravity on the pulmonary function, or the PUF experiment, involves inhalation and exhalation tests taken periodically and before and after a subject spacewalk. We now have another video. To support materials processing experiments, Expedition 5 crew member Dr. Peggy Whitson is shown here training with a glove box. Control panels provide an interface to monitor and control the power, data, cooling, and video resources that are integrated into the work volume. Using the gloved access, the operator can manipulate components and connect resources. The MSG allows the crew to work safely with experiments that involve fluids, flames, particles, and fumes. This chart shows the setup for the first investigation that will use the MSG facility. The solidification using a baffle in sealed ampules, or subset, is an investigation in which dopants are added to molten specimens in the furnace, then cooled to form a single semiconductor crystal. This view through the glass of the MSG work volume shows the components of the subset experiment. The furnace is the rectangular box in the chamber left. The rightmost portion of the furnace is of a translucent material, allowing the camera and spotlight, which are in the foreground center, to view and relay images to the investigators on the ground. Two systems on board which measure and record vibration levels are the Microgravity Acceleration Measurement System, or MAMS, and the Structural Acceleration Measurement System 2, or SAMS-2. MAMS measures acceleration when the vehicle responds to drag or crew push-off in exercises. SAMS-2 measures vibrations induced by motorized equipment such as pumps, fans, and compressors. The upper photo shows a SAMS-2 sensor unit with two smaller, relocatable sensor enclosures. The remote units are wired to a rack-mounted control unit which relays the data to the ground. Investigations of protein crystal growth will also continue on this expedition. Protein crystals form from solution in a temperature and moisture-controlled environment. A single thermal enclosure, shown on the right, provides the temperature and absorption control to optimize this process on orbit. After returning to labs on the ground, the large and high-ordered crystals formed in weightlessness support more accurate three-dimensional mapping of macromolecules in the technology of structural molecular biology. This research may lead to a better understanding of how these compounds function in a wide array of biological processes on the ground. A new ADVASC, or Advanced Astroculture investigation, occurs during this expedition. ADVASC is a commercial payload, and its hardware has flown on expeditions 2 and 4. The crop for this expedition is soybeans, and the objective is to find microgravity-induced soybean characteristics which improve the crop's productivity on the ground. Zeolite crystal growth, or ZCG, is also a commercial payload. This will be the second increment for the ZCG operations. Zeolite crystals have commercial applications as catalysts and absorbents. This investigation is extremely sensitive to vibrations during its first few hours, and hence is installed in Express Rack number 2, which is equipped with the ARIS Active Rack Isolation System. The Microencapsulation Electrostatic Processing System, or MEPS, is a new commercial ISS investigation. Multi-layer microcapsules hold promise as a targeted drug delivery system for a number of illnesses, including insulin delivery for diabetes and chemotherapy treatment for cancer patients. STELSIS is another new commercial investigation for Expedition 5. STELSIS investigates the performance of human liver cells in a microgravity environment. The cells are launched frozen. On orbit, the cells are injected into the pink liquid tissue culture modules shown on the left. The tissue culture modules are then inserted horizontally into the BSTC, or Biotechnology Temperature Specimen Controller, on the lower left, where they are incubated for several hours, allowing the liver cells to process various toxins or drugs within the culture. At specified intervals between 4 and 32 hours, the cultures are removed from the incubator and frozen for return and analysis to Earth. For those interested in more information on these research investigations or any other NASA research, there are two very well developed and extensive websites. One is research.nasa.gov, and the second for Earth imagery is eol.jsc.nasa.gov/SSEOP. This concludes the overview of the Expedition 5 Science Program. I thank you for your attention, and I'd now like to turn it over to Tina Melton, the Lead Payload Operations Director.
Thank you very much, Vic. I'm happy to be here this afternoon to talk to you about the payload operations that we have planned for Increment 5. First of all, I want to talk to you about the role of the Payload Operations Center located at Marshall Space Flight Center in Huntsville, Alabama. First slide, please. The Payload Operations Center is the science command post for station and consists of a team of flight controllers who are responsible for the integration and operations of the payloads that are flown to the station. We have been supporting operations 24/7 since the beginning of Increment 2 in March of last year and serve as the interface between the scientists on the ground and the crew on orbit to operate the experiments and accomplish the scientific objectives. Prior to flight, we worked with the science community to develop the plans, procedures, and products required to execute the flight. We also trained the crew and ground support teams to perform all of the activities required to implement these plans. In the timeline, we have planned 233 hours of operations to be performed by the station crew, and in addition, we have a number of payloads that will run continuously throughout the course of the increment. These payloads will be controlled by ground commands from our operations team in Huntsville and also the science teams at the remote sites across the U.S. Next slide, please. This map of the U.S. shows the location of the science teams that will be supporting this increment. Most of these remote sites have been online during the previous increments. New additions are the Microgravity Science Glove Box team at Marshall and the Microencapsulation Processing System team here at JSC. As you can see, there are scientists and engineers across the country located at numerous universities, corporations, and telescience support centers involved in the operation of the payloads. As the experiments are operated, health and status information on the hardware, as well as science data, are transmitted from the station to the Marshall Center, where it is processed and then routed to the appropriate science team. These teams then evaluate the data to make sure that the payloads are operating correctly and achieving their scientific objectives. They can then send commands back up to the station to support these operations and can also make adjustments that may be required. One of the major accomplishments of the space station program has been to develop the capability to allow the scientists and engineers to stay at home and operate the payloads from their home base. Next, I'd like to give you a high-level overview of the schedule of activities that we have planned for the Increment 5 crew. As Diane talked about earlier, there are a number of EVAs and progress dockings that define the backbone structure of our operations. We have then gone in and overlaid our payload activities based on their scientific requirements and operational constraints. Express Rack 1 is operated throughout the increment and supports the two acceleration monitoring systems that Dick talked about earlier. These acceleration accelerometers measure all vibrations that occur in the lab and are used by many of the scientists to aid in the evaluation of their science data. Express Rack 2 is where we will be processing samples in the zeolite crystal growth furnace. The Aeris vibration isolation system in that rack will be used to damp out any motions that may impact the growth of the zeolite crystals. Express Rack 4 is the location of our continuously powered payloads. These payloads are all very sensitive to power interruptions and have stringent requirements that must be carefully monitored by the crew and the ground teams to maintain the viability of the scientific samples. A couple of the payloads located in this rack are the commercial Stealthus and the ADVAS plant growth experiments that Vic showed you earlier. Samples for both of these payloads will be brought to the station in the shuttle middeck and then processed by the crew a few days after shuttle undocking. The Stealthus Looper cells will be frozen after processing and returned home on the 9A shuttle flight. The ADVAS hardware is used to grow soybeans. We have scheduled 66 days of plant growth, which provides enough time for the plants to mature and flower. The growth phase will then be ended and the plants will be dried and harvested by the crew for return on the next shuttle flight. This is the first flight of the Microgravity Science Glove Box. During the shuttle flight, the crew will transfer the rack from the multi-purpose logistics module to the U.S. lab. Later, Peggy Whitson will perform the on-orbit commissioning procedures, which will check out the hardware. A team of engineers at the Marshall Center and at the European Space Technology Center in the Netherlands will evaluate the performance of the hardware to ensure that it works correctly and is ready to support on-orbit operations. Afterwards, Peggy will install the SUBSA furnace and later the PFMI furnace, where she will process a total of 16 different sample ampules. The Human Research Facility is currently on orbit and will continue to support a number of life sciences experiments that will use the Increment 5 crew as research subjects. These experiments are conducted over the course of the increment and collect data and samples on a regular basis as required by the scientists. Next slide, please. One final thing I would like to tell you about is our website. It is located at SciPOC, that's scipoc.mssc.nasa.gov. It contains a lot of information about our station payloads and their ongoing progress during the course of the increment. It also contains a tour of the Payload Operations Center and information on the flight controllers who are responsible for conducting the payload operations. As you can see, we have a very ambitious program of science operations planned for Increment 5. The flight control teams at the Payload Operations Center and the science centers across the United States will be working very closely with the Mission Control Center here in Houston and the crew on board the station to operate the planned experiments and return data and samples to the ground for the analysis and review of the scientists. Thank you very much.
Thank you. We'll start with questions here at Johnson Space Center. Okay.
Dave Santucci from CNN. How much time are the Expedition 5 crew going to be able to dedicate, either, I don't know if you can break it down per day, per week, towards these experiments, as opposed to, the maintenance they have to do on the station, sleeping, other things? But how much time are they able to put towards these experiments?
Typically, we try to plan for about 20 hours per week of crew time to devote. Some weeks we can do that, some weeks we can't. The weeks we have EVAs or spacewalks, we typically can't get 20, but we try to do at least 7 or in that vicinity to make sure everything is maintained in the, that needs to keep running in the way of the experiment. And then on the weeks where we don't have the major events of the spacewalks or the progresses, then we try to get more. But on the average, it's about 20 hours of crew time. I mean, there's additional scientists being done, as both Vic and Tina talked about. 20 hours a week.
So the percentage of these experiments need basically no attention, can just run on their own.
I'll try to answer that one. Well, let me start off by pointing out that 6 of the 10 human life science experiments require no in-flight crew time. We refer to those as pre- and post-flight baseline data collection only. Of the remaining 19 investigations which do require in-flight time, I would say about a third of them are basically activate and then leave sit until you deactivate. So probably an hour at the front and an hour at the beginning. The remainder do require some attention, particularly the MSG payloads, which the SUBSA investigation, there we plan one run every other day, and each run lasts about 10 to 15 hours. Now, it doesn't take continuous crew time, but it does take an hour or two for each run to start and end that run.
And, I mean, because of the limited crew time, does that affect the way that the experiments are chosen for future missions, and how much, I assume you put a considerable amount of thought into how much time the crew is going to need in order to do an experiment. So are there experiments that you're unable to do because of limited crew time?
Well, let me answer that this way. There are really 2 limiting resources to conducting more investigations on the ISS at this time. The first one is upmass. That is by far the limiting resource. And if we are able to get past that one, then the second one would be crew time. At this point, we are not limited. We have not left investigations on the ground because of lack of crew time.
Okay, Mark?
Mark Carreau from the Houston Chronicle. I think it's for Dr. Cooley. Could you just refresh how many racks do you think you'll have on the station at core complete? And I have a second question.
Well, at core complete, we are aiming for 10 science racks on the ISS. This will bring us to a complement of 7, and on flight ULF-1 next January, we plan to deliver the remaining 3. which will be the HRF rack number 2 for the Human Research Facility, the wharf or window observation research facility, which will actually sit over the window and form a camera platform with various enhancements to the ability to take pictures without crew involvement. And the last rack would be the Melfi, which is the -80-degree freezer.
Okay, thank you. And I wondered on this mission, could you touch on some of the major experiments that will have equipment or medical specimens coming down to the ground, returning to Earth on 111?
There are, yes, a number of investigations that have completed on this past stage. One of them is the BPS, or Biomass Production System. This was another experiment that grew plants. I believe it was wheat in this case, and grew those plants through their full life cycle. The Eris ice experiment, which has been run over the last 3 increments, is concluding. The EXP-PCS, or Physics of Colloids in Suspension, is concluding. The CPCGH, which is a commercial protein crystal growth experiment, is also returning to Earth.
Okay, do we have additional questions here at Johnson Space Center? Seeing none, we'll go to NASA headquarters in Washington for questions.
Tracy Watson with USA Today. I know in the past some of the increment members have had complaints about time management and scheduling, so I'm wondering if you could talk a little about how you're handling this time around, how busy they'll be, and how you'll ensure that they have some time off.
Well, we have put some guidelines in place to try to assure that the crew has adequate time off. They're given most of the weekends, and we have time at the beginning of each day to ensure that they have time to get themselves ready for each day, time to do their daily planning, as we call it, that we send up the information and get a chance to look over what they're going to do for the day. And then from, I believe it was increment 2, or the Expedition 2 crew, there was a new process that was put in place where we provide the list of things that we would anticipate that they would get done for the day, and instead of scheduling them by time, let the crew do their own time management up there. When things have certain times when they need to be done, when you need to coordinate with the ground or whatever, then we give them a certain time to perform that activity. Otherwise, we give them the list of items to be accomplished. And we have had great success with this with the crews that have been operating on orbit today.
Hi, Bill Hart with CBS with a dumb question that I just can't remember the answer to. The original UF designation for these flights was congressionally mandated, I guess, back in the Freedom era. Am I right about that? And is UF now simply a holdover from those days, or does it have any significance whatsoever to the original congressionally mandated research during assembly? I mean, this is obviously the same as any other flight, roughly, that you guys are doing now. Just trying to make sure I understand the nomenclature these days.
Well, UF refers to utilization flight, which means we're bringing up a lot of provisions for the crew on orbit and all the systems, hardware that they need. Now, its origin, I cannot tell you. I was not part of the station program back in the Freedom days, and I do not know the origin there. I just know today the UF designator is utilization flight. This is our second one, therefore UF2.
Yes, let me add to that, Diane. Recall this is a MPLM flight, so we do have extra launch capacity, and that is why we are launching 2 new science racks, as well as 1 locker-sized refrigerator freezer, which is another facility for the science payloads on this flight.
Very good. We'll go to Kennedy Space Center and take questions from reporters there now.
This is Phil Chen, Earth News. I realize no U.S. EVAs are planned, but if they are, who would, obviously all 3 crew members are trained, but who would the prime crew members be if some U.S. EVA is needed? And will the puff and the radiation experiments be done using, I suppose they have to be done using the Orlons. I seem to remember the Expedition 4 only did some of those experiments after the EMU EVAs.
I'll take the first part of the question. You can take the second part. The first part, if we end up doing a U.S. EVA, again, all 3 crew members have been trained, but the specific ones that we have, it's more likely to be accomplished, will be done by Commander Corzine and Peggy Whitson.
Actually, the EVARM experiment is done with the U.S. spacesuit, and it is done on this and all assembly flights, I should say shuttle flights, by the shuttle crew going EVA. So there are 3 EVAs on this shuttle flight, and those crew members will be the subjects. The shuttle crew members will be the subjects. The ISS crew is required to read the badges and actually insert the badges into the spacesuit before and after the EVA.
Okay, but puff and the radiation will not be done on the 2 Orlan EVAs?
I don't recall if puff is done on EVAs involving the Orlan suits. Certainly it is done on the U.S. EVAs.
John, you already told us we should treat you nicely, so I'll give you an easy one now. For the semiconductor dopant experiment, what's the semiconductor substance and what's the dopant substance?
You caught me there. That's I can't recall those chemicals offhand.
Okay, I think I need an easier one then. Do you know when the Kronk materials exposure experiment was put in place? Was it launched with the service module, or was it one of the ones done on our earlier expedition to EVA?
I'm afraid I don't know the answer to that one either. We are improving our coordination with the Russians and trading information about the investigations that each side does. At this point, we do get information regarding the names and a very brief description of each Russian investigation. That has been an improvement that we have made in the last year.
I believe the Kronk experiment was placed out in an EVA in a previous increment, but I don't remember if it was increment 3 or 4. I believe it was 4, but I'm not sure. We'd have to verify that.
This is Kelly Young at Florida Today. I was wondering if you could tell me a little bit more about the glove box. For example, how is it different from the one that was on Mir?
Well, the volume is twice as big for starters. It is a full rack volume and size. It does have quite a bit of resources and connections, including video, which is very important for the investigators to be able to see high quality close-up video, and for that video and the lighting and the specimens to be easily manipulated.
And one more for me. I'm sorry if I missed this, but do you know the number of Russian science investigations during this increment?
I recall that it is in the 30s.
I'm Todd Halverson, New York Times, for Diane Murphy. Each of the expeditions to date has had a certain character or flavor. The first being described as a shakedown cruise, the second was, I think, billed as a startup of science. And I'm wondering how you would describe this particular Expedition 5 increment.
Well, I guess I hadn't really thought about it, but I would probably say it's a continuation of the science, and including when the shuttle flights arrive, a continuation of the expansion of the station itself. But we're trying to get down to basically daily business on orbit with the facilities that we have on board until we get a new capability up there. So I would say we're just continuing the science and the operations that we do on board the station every day.
And a quick follow for Dr. Cooley. I'm wondering how you would describe the content of the science research program for this expedition overall in terms of its complexity and diversity as compared to what has been done to date on previous expeditions.
Well, I would characterize it as being slightly more diverse because we now will have the microgravity science glove box. It is slightly more diverse in the commercial area because we've added the Stealthus experiment. It is on par aggressively in terms of getting the amount of crew time required to operate these investigations. So that's how I would characterize that.
This is Jim Banky of Space.com, and the question I'm about to ask is at its heart a question about amount of science on board versus other things going on. Now I'm going to ramble for a minute. If I've done the math right, you're staying up for 19 weeks with Expedition 5. You said 20 hours a week, 233 hours of in-flight crew time. That's about 12 weeks, 20 hours each. The percent of that is about 7%, a little bit more than that. During a recent in-flight PAO event, Carl Waltz was asked the question. He said, well, we're spending about 60% on science, 40% on everything. And then he corrected himself. Well, actually, really, no, it's more like 70% science, 30% not. Folks in Congress say, you know, you're lucky to do 10%, and why aren't you spending more time on science? So that's kind of like a rambling, a lot of different phrases there. How would you guys characterize right now where you're at, really what's the value of the science and how much science you're doing up there, and how much more should you be doing or could you be doing?
Take a crack at that? Well, let me start by saying that the crew day is 6.5 hours long. This is because there are exercise requirements on the order of an hour to an hour and a half per day outside of that 6.5 hour day. In addition to that, there's normal housekeeping and family communication that the crew member is certainly entitled to. So we start with 6.5 hours times 5 days per week. We also have to subtract holidays, and when the crew, after the crew arrives, they are given 2 days extra off just because they have spent the entire docked mission unloading cargo and reloading the orbiter with spent cargo, so they probably missed a weekend in there. Additionally, you can't simply divide the number of hours by the 19 weeks that you mentioned. It sounds like that 19 weeks, if I'm recalling correctly, includes the docked time. We don't get the time for utilization except that which is absolutely necessary to keep any science investigations from outright dying. We don't get that time during the mated phase. If there is an EVA, a stage EVA, this also reduces time when the orbiter is not there. And so after you take all these things into consideration, even though we shoot for 20 hours per week as a guideline, experience on the first or experience on the last 3 increments has averaged to somewhere between 17 and 18 hours per week for all utilization.
And I believe that was the last question at Kennedy Space Center. We'll come back to Johnson Space Center for any follow-up. Any questions here at JSC? Seeing none, we'll adjourn the briefing. Thank you very much.
Good afternoon and welcome to the pre-flight briefing for the Expedition 5 crew that will travel aboard STS-111 for their 4-month stay on the International Space Station. We'll begin with some short introductions and comments about the mission and then take questions. The expedition commander is Russian cosmonaut Colonel Valery Korzun. He's a space veteran who has spent 197 days on Mir 22 from August 96 through March 97. He's a graduate of the Military Aviation College in Russia and serves as a military pilot. And with that, I'd like to turn it over to Valery to introduce his crew. Valery.
And Expedition 5 crew includes 3 crew members. I'm Commander Peggy Whitson, Dr. Peggy Whitson. She is flight engineer, number 1. Her main responsibility, it's American segment, and of course, all station. And Sergei Treshchev, flight engineer 2. He is engineer of Energia plant from Korolev. I have small experience to fly in space. Our crew member Peggy and Sergei, unflown astronauts, cosmonauts.
Thank you. Peggy, do you have any comments?
Yeah, I just wanted to add that we're really looking forward to our mission. We have a lot of interesting participation in some interesting assembly tasks during our flight. when we go up on STS-111, we'll be installing the mobile base system. Valery will be assisting in some of the SSRMS support during EVA number 1, and he will be providing some support during EVAs 2 and 3 as well. And Carl and I will actually, Carl Waltz, who's Expedition 4 crew member, and I will actually do the installation of the mobile base system onto the truss. And throughout that mission, we have a lot of responsibilities, all three of us, in emptying out the MPLM, which is going to carry up much of our logistics, not only for our expedition, but for Expedition 6 as well. So we've got a lot to do in a very short period of time. And then we also have another shuttle flight that will come visit us around August sometime. And they'll be bringing up the S1 truss. We'll also be participating in SSRMS support for those tasks, and the installation of the S1 truss, which will be pretty impressive. I think it's as long as the P1 truss, or the S0 truss that was installed on the previous crew. And it fills the payload bay, so it's a pretty large section of truss that we'll be adding on. And then the flight that we come home on, 11A, will also be bringing up the P1 truss. In between those times, we will be also doing a number of other tasks. We've got some EVAs. Valery and I will be doing one EVA out of the docking compartment, and then Sergey and Valery will do another EVA out of the docking compartment during our expedition as well. And then, of course, we've got lots of science to entertain us along the way. So we're very excited about the flight. Sergey, did you want to say anything?
I would like to say the ISS is designed as a science laboratory and a place to develop technology and foster commercial research and development. And it's very important that many nations will be work together inside ISS to develop space research, and so that many people can fly into space soon, maybe. Thank you.
Okay, thank you, Sergey. And with that, we'll go ahead and start taking questions here at Johnson Space Center. Mark, please, first.
Mark Carew from the Houston Chronicle, and my question is both for Commander Korzoun and Dr. Whitson. This crew has 2 first-time space flyers and 1 veteran commander. What challenges does that present in planning your pace of work and activities? Is that a factor at all, do you think, in what lies ahead for you?
You know, we had enough time for training, and we had really good training for our expedition, for our task. But it seems to me it's more important. Sergey and Peggy, they are unflown astronauts, but they had very nice training and they ready for flight. And I think it will be a little difficult for unflown cosmonaut and astronaut to imagine a real situation on station, because we had good training on a simulator, on laboratory here on the ground, but real station not the same as here on the land. But this is first. But no, I think we have enough time for handover, and previous crew will familiarize us with situation on the station, and we need to short time understand exactly all configuration, all system, and all equipment which storage in the station. And in case if somebody of us will have a short period of adaptation for weightlessness, and medical specialist will help us to to do this, to make this period more successful for our activity. And of course, during our joint mission with UF2 and Expedition 4, we will be support of previous crew, Expedition 4, and Shuttle crew member 2. And our flight, I think, will be interesting because Peggy said and Sergey, we will work together with 3 shuttle crew. This is UF2 or 9A, 11A, and we will provide docking and mate MBS S1, P1, and we accept 2 cargo. Now we are waiting for 2 cargo ship on space station, and we're going to make 2 EVA, and we are ready for cleanup task and for emergency EVA. And I think we will have a very tiny schedule during our flight, and it will be interesting time for us. And I'm sure that crew members are ready for our task during our mission.
I think Valery covered that pretty well. I do think that our training has been adequate. I'm looking forward to it, and we obviously can't say exactly how we'll react to being in space since it will be our first time, but we're looking forward to the task, and maybe because we are first-time flyers, we're going to be willing to work even harder.
You have a follow-up, Marcia? Yep. Okay. Marcia.
Marcia Dunn, Associated Press for Dr. Whitson. You've observed many space station crews over the years with a trained scientific eye, and what do you think is going to be the most challenging part of space station life to you once you start racking up the months? Homesickness, stir crazy, just overworked? I mean, what do you think will be the toughest thing for you to go into this?
I think probably the most challenging thing after some period of time of being in space is just going to be missing the Earth. I'm an outdoors person. My hobby is working in the yard with my plants, and so I think I will miss just the planet, being close to the plants and the planet itself. But it's obviously a phenomenal view, so that'll give me a new perspective from which to look at it. So I'm looking forward to the experience.
And for Commander Korzun, you've already spent 6 months at a time in space, and was it easy for you to spend so much time? Was it difficult? What for you was the hardest thing to be in space for so long?
On the other hand, this is easier, but on the other, this is difficult. Because if cosmonaut astronauts usually have a very tiny schedule and a lot of activity, and we want to do as much as possible during our flight. It's interesting. In 6 months, it doesn't matter in this case. But of course, we are missing of our friend, land, and family. I don't know, pets or something. But especially, Peggy said about her yard. She will think about yard every time, because on the station interior, this is just only fabric, metal, or something. And during our flight on Space Station Mir, there was a greenhouse, Mexican plants inside, and everybody had chance to look at this green plants in the greenhouse. It was very nice support, psychology support. But I think we will grow something on stage.
We will.
Because Peggy has good experience.
We've got a couple of experiments that we'll have some plants involved, so that'll be fun for us.
Next, down here, please.
Dave Santucci with CNN. My question is for the commander. You were on Mir during the fire. I'm just wondering, how do you deal with a crisis in space, and what have you told your crew about dealing with that sort of emergency situation?
You know, this situation described in a lot of books, not a lot, but some books looks like Dragonfly, Of the Planet, Jerry Linenger. By Jerry Linenger, they talk with participants of this situation, and everybody have had their personal opinion about this one. But you know, it was very easy because not very easy, but when crew member knew about fire, and everybody knew their duty, activity, you know. And we have short meeting before, after fire, and we separate our activity. One of them prepare station for in case for evacuation, another kill fire. Jerry Linenger provide medical operation if we will have medical emergency. And another crew member help each other and check each other, control the situation. And you know, maybe first of all for us was more important to extinguish fire, but another task, it was to clean atmosphere, because if we cannot clean atmosphere, we cannot live in station. It was successful finish, and we extinguished fire, clean atmosphere. We had a lot of problem with health of crew member, and later just only ground can analyze contaminants in atmosphere and the water, and it was pretty well for life on station.
Okay, thanks. My second question was for Peggy. I know you're sort of a scientist by background. What is your favorite experiment you're going to be working on while you're up there?
Well, I'm interested in a lot of them. I think they're all going to be pretty interesting. One in particular I'm interested in is Stealthus. It's a commercial payload where we're going to be culturing liver cells. And since I have some background in cell culture, I'm very interested in doing that activity. We're also taking up on UF2 the Microgravity Sciences glove box. It's a facility-sized rack that will allow us to contain more hazardous and toxic materials and do experiments on them inside that contained environment. And so we have a number of different types of experiments going on inside there, and that provides a new capability for the station. So I'm looking forward to those experiments as well.
Okay, thank you. Do we have any other questions down here? Let's go back to Mark, please.
I'll ask this question, I guess, to whoever would like to answer it, but I'm sort of wondering if you sort of looked at the evolution of the space station to date, and you look at the contribution you're to make, can someone sort of thematically explain how the whole process will evolve during your stay?
Well, I think probably the biggest contribution in terms of the actual assembly process, the mobile base is going to allow us to move the arm around. It gives us a mobile platform for the arm. I think that's going to be, it's absolutely critical for the continued assembly of the station. Without our ability to have the mobile transporter, which will be sitting on top, or the mobile base sitting on top of the transporter, move to the end of the arm to add the additional truss structures, we would not be able to complete that assembly. So I think that's a key part, and obviously the truss structure itself provides the backbone for what will be the structure that holds the solar arrays. So I think, you know, there's just basic building blocks that are adding up to the future of the station, which in its entirety will be pretty impressive and expansive, since the solar arrays will extend the length of a football field from one end to the other.
Thank you. And I wonder, each of the last 3 crews at least has shown a pretty intense interest in keeping a pace or abreast of events on the Earth, because they've been pretty dramatic since last September. and just maybe their own personal interest in one area of public affairs and another. Is your group doing anything different, adding, changing? How do you kind of want to keep an eye on the planet Earth while you're in space?
Do you want to take that?
If I understand exactly the question, because I don't use interpreter, I'm sorry. But you know, our crazy mirror, when we have a lot of problems with terrorists and with terrorist attack in different countries, I think our activity will show that our country, not our country, I mean US and Russia, a lot of countries which continue assembly of station, continue build station, show this best way in the world for cooperation, for activity, joint activity, because I think this is future. Attacks and explodes and threats. This is its event has no future.
Yeah, I think the ground has been pretty responsive to the individual characteristics of any crew. For instance, not just terrorist things, but sports events. If Sergey's interested in soccer, and so he wants to have soccer scores sent up, and you know, so they're pretty adaptable in sending up the information that's of interest to us, just in general, as well as anything specifically, like a big event like September 11th.
Okay, with that, I guess we have one more question here in Houston, and then we'll go to headquarters.
Marcia Dunn, Associated Press. Who's going to get the lab for sleeping purposes? How are you going to divvy up the bunks?
I've got the laboratory. I got dibs early.
Okay, and with that, let's go ahead and go to NASA headquarters. I think we have a few questions from there.
Yeah, hi, it's Bill Harwood with CBS News, and Dr. Whitson, for those of us who can't participate in one-on-ones later today, I just wanted to get a little bit of a sense from you about if you could maybe just tell us a little about the chemistry that you guys share, not science-wise, but just how you guys work together as a crew. I'm assuming with the three of you, with two Russians and one American, that Russian is pretty much what you guys talk when you're by yourselves, and just for the record, I assume you're fluent, but could you just talk to us a little bit about language? And can you give me a little sense of what you will do when you do have a minute of spare time, and what kind of books you like, music, that sort of thing?
Well, language, I think, is probably the hardest thing that I've had to do in preparation for this flight. I'm not a natural at learning the language. I've come a long ways, and I think that the three of us can communicate pretty well. We end up mixing and matching languages sometimes in order to communicate most effectively. Valeri's English is very good, and Sergey's come a long ways. So we can mix and match in languages to communicate very well. It's interesting when we train together. When we train in the U.S., we speak almost entirely English, and then when we train in Russia, we speak almost entirely Russian. So it'll be interesting to see what language we live with and work with on the station. I wonder if it'll be segmented, depending on what module we're in. But I think we've trained well enough and long enough together that I don't anticipate that we'll have any problems. I think we have a good mix of personalities. Valeri's pretty outgoing and quite the joke teller and storyteller, so he entertains us quite a bit. Sergey and I, we can add our own entertainment at times. So we're looking forward to working together. In terms of things that I'd like to do while I'm on orbit in my spare time, it's hard for me to envision that there will actually be spare time, but I imagine that there will be. Obviously, looking at the Earth is going to be pretty interesting for me, And one of the things I've taken along is a computer course to learn a little more about geography, so I can learn more about all the countries as well as learning where all of them are located. And I've got the ideal viewpoint from which to learn. So that's one thing I'd like to accomplish while I'm on orbit, just for my own personal satisfaction. And of course, all of us, I think, have books and music of our particular interest. And then on the station, there's quite a supply of movies in English and in Russian. So I'm sure we'll have plenty to entertain ourselves if we find we have any free time.
Thanks. Are any of you guys musicians, Dr. Whitson? I mean, I know you got a keyboard up there, and I guess there's a guitar of some sort, I guess. Do you guys play, and what kind of books and movies do you like, if you don't mind me asking?
Well, Sergey plays a little guitar, so he's going to be entertaining us. And actually, he sings very well as well, so we're looking forward to hearing more from him.
I would say I try to play guitar, but not professionally. I like sing song. I like to play guitar, and if we will have some free time, of course, I will try to sing song and with Peggy, with Valery,
yeah.
And maybe we learn to play keyboard.
Yeah, maybe you'll learn. I don't think I'm up for that.
Yeah.
But the rest of your question on what books I'm taking, actually, we had to stow the books so long ago I don't even remember, so it'll be a surprise to me what they are. But in general, like science fiction and mystery stories, detective stories.
Tracy Watson, USA Today. I know one of the previous ISS crew members, to prepare for her flight, went so far as to put all her belongings in storage. And I'm wondering what kind of steps the three of you have taken to, settle your affairs here on Earth before going.
Well, for me, I think my husband might be a little upset if I put everything in storage while I was gone. So he'll be taking care of the house. Did you do anything special?
Storage.
Yeah, yeah.
No, this is a question for American. Remember, for us, no, we had the same problem.
Okay.
Okay, and I believe that's the last question from NASA headquarters, although maybe we have another one.
On so long, are you basically just, leaving it all, not making too many provisions, or can you name some specifics, perhaps?
Well, one thing in particular I did do is, since my husband was going to be in charge of all my plants that I have in the yard, I moved a bunch of sprinkler heads closer to the flower beds so that maybe some of my plants would survive.
All right, with that, we'll move to the Kennedy Space Center. I believe we have about 7 questions coming from there.
This is Coach on Earth. As Peggy, I hope you also have somebody to help babysit those plants. But for Peggy and Sergey, given your commander's previous experience on his spaceflight, especially the last couple of weeks of his somewhat exciting mission, are you folks bringing any good luck charms or doing anything special to hope that you don't have as an exciting mission as he had?
Well, the biggest good luck charm we're bringing along is Valery. We figure he can handle anything. But
additional extinguisher.
Maybe Valery says maybe an additional extinguisher, but I don't have anything in particular. I'm not a particularly superstitious person, so I don't have any good luck charms. Sergey, are you bringing any good luck charms?
As to the talisman, my children gave me some soft toys to remember East, to remember family, to remember and to help us to fly in space. But as to special talisman, I think no.
And Peggy, I realize it's a standard procedure for Russian cosmonauts to be prepared for long-duration missions on their first flights. But the last time a U.S. rookie astronaut went up for a long-duration mission as their first flight was Skylab 4. And when you got up there, if you suddenly find out you don't like long-duration space flight, it's not like you can give your Sokol suit to Franklin Chain Diaz and say, here, let's swap seats. Any concerns that you have that you may turn out to be that it's not your cup of tea?
I can't imagine not enjoying it. I've wanted to do this for so long that I just can't quite imagine not enjoying it. And I know that some people will be more or less able to adapt to the change of the initial phases during spaceflight and living in space, and some of that may be challenging initially. If I happen to be a person who gets sick easily in space, then that might be very challenging. But all the long-duration crew members say that you will become adapted. It might take you a little longer, but you will become adapted. And so I'm really looking forward to all our activities during our mission.
And for Valery, this mission was originally supposed to launch from Baikonur in the Soyuz. And how do you feel about the fact that you're flying the Shuttle instead of the Soyuz? And can you tell us how that decision happened?
I think this is easier for us to have launch on the Shuttle because we have a lot of activity in the Shuttle. If we had launch on Soyuz on Baikonur, this is a little different. But for us, doesn't matter which vehicle will bring us up to the station. But for me, it will be my second flight, and for me, it's interesting to use shuttle vehicle as transport to bring me on the station. Because during my mission on Mir, we had two docks of shuttle STS-81 and 79, I think. And it was interesting to watch this picture on 100-ton shuttle and 100-ton station docked together and flew together. But I think our crew will be happy to fly on the shuttle. And one more important thing, of course, landing on the shuttle will be easier for a crew member who were in space long duration flight, because shuttle flight and shuttle profile during re-entry, this is not the same than profile for Soyuz, and of course G not the same. I mean gravity on Soyuz and shuttle different a little bit.
Hi, Peter King with CBS News Radio. This question's for Dr. Whitson. I kind of liken what you're doing to, say, a rookie pitcher starting the first game of the World Series in his first major league start or professional start. You get a chance to go on a long duration mission your first time out. You also get a chance to go EVA. Just wondering what your first reaction was when you found out you were going to get to do all of this on your first space flight.
Well, I was very, very excited. I really, when I became an astronaut, I was looking forward to the fact that the station at that time was just beginning its construction, and I was looking forward to the time when I would be able to spend time not only working in space, but actually living in space and getting a feel for what it's like to be there long duration. Your description of it makes me a little nervous in the sense that I didn't realize I was under that much pressure, but I'm looking forward to the opportunity to try and help out in this process of assembly.
Things from your family about being away for so long, not just for this, but because you were training so often overseas?
My family, I've been in the Houston area for a little over 20 years now, And so I've been away from them. All of them still live in rural Iowa. And so I visit them once or twice a year. So I think it won't be all that different, especially with the telephone access that we have. We can call the ground, so I'll be able to call them and talk to them on a regular basis too, and let them know what I'm doing with email and phone calls. So I think they're pretty excited too.
And this question really is for all of you, but especially for Commander Korzoon, because you really grew up during the space age and you were born before Sputnik went up. The Chinese are now saying, at least one of their newspapers is reporting today, that they want to send a man to the moon by the year 2010. Because you've been around and you know how hard it was for the U.S. to do it and how hard it was for the Russians to be in the space race at all, I'm just wondering what you think of that. Can it be done in 8 years?
I think most important to provide space program, common space program. I mean, some space program should be international space program because nationality program. I mean, not just only Chinese. They couldn't provide something more interesting than we had. I mean, experience of our country to fly in space. And I think if China want to have their personal program, space program, and they have money for this program, why not? But I think this is it will be not more modern or more interesting than International Space Station, because International Space Station, this is really international project, and a lot of countries built this station, and a lot of high-tech technology high technology of that country used during this assembly and during building of the station. It looks like SRMS, Shuttle, and Russian module and engine and something. But I don't know. Time will show who was right.
This is Jerry Hannafin of Time Magazine. It's another one for you, Dr. Whitson. I think we've never had an astronaut flying before who flies with a couple of patents to their credit. And what inspired your research into this particular area where you come up apparently with some real-time analysis of hemodialysis, which takes a long time here on Earth? Will you tell us what inspired this and how this system works, please?
Well, actually, the inspiration for the project was during Shuttle Mir, when we were working together with the Russians. We didn't know if we would have capability to freeze blood and urine samples that we needed to bring back to Earth for analysis. And so we were inspired by the fact that we thought we had to come up with a technique that would survive room temperature storage and ideally didn't require a centrifuge. So our process separates the blood cells from the plasma and allows us to dry down the plasma and bring it back to Earth, rehydrate it, and do the analysis and get quantitative results. And so that's what the patents are on. But I do think there are several other astronauts who do have patents. I think one of our crewmates, Dr. Franklin Cheng Diaz, who's flying up with us on 111, has some patents as well. So.
This is Jim Banke with Space.com. Another question for Dr. Whitson. Understanding your Iowa background and your talk now about you're interested in growing things, but basically you're launching and you're going to miss summer on Earth. So I kind of have two questions really. That one, do you feel like you're leaving the planet for the next few months, or only less than 300 miles up, not that big of a deal in terms of leaving the planet? And secondly, you know, from orbit, do you have any plans to watch the growth of vegetation across like North America? I mean, can you tell from the space station if the corn is knee-high by the 4th of July, Iowa?
I don't know if we can tell if it's knee-high or not, but I do think we can monitor the vegetation and its growth. And actually, we have a number of different scientific investigations looking at coral reefs from the orbit, looking at deltas and how urbanization is affecting the development of deltas. So there are a number of different investigations where we'll be observing the Earth from orbit. And I think as part of that process, yes, we will get to observe how the vegetation is doing. And the interesting thing is we get to see the differences in the northern and the southern hemisphere all at the same time. So we get to see kind of the seasonal differences as well.
Part of that, do you feel like you're leaving the planet? Do you feel like you're leaving Earth, or would you have to go to the moon before you felt that?
I think I feel like I'm leaving Earth because I just won't have access to the things that we do in everyday life here. Going out the door isn't quite as easy there. But I am looking forward to that opportunity as well.
This is Ocean Earth News for Valeria. As long as we're talking about seasons, your last mission overlapped the American football season, and your cosmonaut engineer, John Blaha, was very excited about the Dallas Cowboys and Green Bay. Yes, you remember. Have you had a chance to follow any American sports since then, or are you interested in finding out about any American sports or activities like that while you're up on this mission?
Of course, we will miss about news of American football, but it's a pity Peggy is not fan of American football. And we haven't chance to discuss about playoff or crew members, you know. But we'll see, because I know if we need to know news, sport news, we can receive this news on station. Thank you for question. And I think John Blaha, he was very nice American football fan. He know all great players and all team, and he knows all news about American football.
I'll pass it on to John when I talk to him. And I suppose a big picture question for all of you, how do you folks get along as individuals when you're not training to fly in space? I see some long duration crews who really get along with each other and really are buddies outside of work, others where it's more professional and you have different interests outside of work. Just wondering what the dynamic is in your particular crew.
I think we have a very good dynamic. We spend time together outside of work, mostly eating, actually. But we do like to spend time together. I think for all of us, our families are very important to us, and I think that's a strong bond for the three of us.
We like very much to be in a Peggy house. She is not just only a good American astronaut, she is a good cooker and organizer of party and everything.
Good morning and welcome to our launch minus 2-day countdown status briefing for mission STS-111. With us today as our briefers are Steve Altimus, Shuttle Test Director.
Good morning.
Glenn Chin, the STS-111 Payload Mission Manager.
Good morning.
And Kathy Winters, our Shuttle Weather Officer.
Good morning.
And we'll begin with a statement from each of these, beginning with Steve.
Thank you, Bruce. Welcome to the STS-111 launch countdown status briefing. All our non-standard or all our standard pad processing activities were completed prior to braking for the Memorial Day weekend. However, late last week we discovered that we had a leaking APU spray valve associated with water spray boiler number 3. Technicians and engineers have been working diligently over the weekend to replace that discrepant valve. We have completed the replacement activity. We've performed leak and functional checks on that spray valve and closed the aft compartment for flight. We're currently on the countdown timeline. No non-standard work is remaining. And I'd just like to comment that that was really an exceptional job by the KSC and vendor team to replace that APU spray valve. It's never been done before in a vertical, and our team really stepped up to the effort and got it done in a timely manner in order to support countdown. As far as the countdown timeline goes, we did pick up call to stations and the count is counting as planned last night at 2300. Today we'll go through our cryo load preps and prep for servicing the power reactant storage distribution system, which will occur all throughout today. Tomorrow, Wednesday, we'll perform our engine final checkouts and pad closeouts for launch, and in preparation for tanking, which is scheduled for Thursday morning with a Thursday evening launch. For STS-111, we're advertising a 4-hour launch period, which extends from 4 p.m. to 8 p.m. on Thursday. Landing, it's a 12-day mission with landing scheduled for Tuesday, June 11th. For scrub turnaround planning, we are planning for a 24 and 48-hour turnaround options, which are available to us. Our planned turnaround support posture is to try 2 consecutive attempts. We stand down then for 2 days, top off both the LOX and the LH2 PRSD cryo consumables, and then try 2 more attempts. And then this results in 4 launch attempts in 6 days. Our PRSD hold limits are 2 days on the LO2 side and 2 days on the LH2 side. And we're not working any near-term range conflicts that would impact us in a scrub turnaround. So in summary, the KSC team did an exceptional job in working through the challenges of replacing the APU spray valve and water spray boiler. And with that activity behind us, we're looking forward to successful liftoff on Thursday evening. I did bring with me a short pad or vehicle processing tape that I'd like to run through for you. If we could roll that. Here you see the culmination of the STS-108 mission. Endeavour's returning from the runway here after a successful landing and mission, rolling into the OPF for a period of about 4 months where we prepared it for this mission, STS-111. Here we're installing engine number 3. It is the 3 Block 2 engines we're flying on STS-111, all of which have flown previously on STS-100, 105, and 108. Here we see Philippe working with some of the tools and equipment that's stowed in the mid-body for this mission. And that's part of our crew equipment interface test, which we run each flow, verify proper tools and equipment. Here you see us accessing the mid-body in the orbiter processing facility, installing a camera. You can see from these views that technicians are in what we call a bridge bucket, and that's the primary means of accessing the mid-body. Here we see technicians working on the main landing gear, replacing and repacking the bearings with grease and installing brand new main landing gear wheels for this mission. Pile technicians working with an electronic step and gap measurement on the several of the thousands of tiles that cover the underbelly of the orbiter. And here we have Endeavour backing out on April 22nd out of the OPF. That activity complete, and we're headed over to the vehicle assembly building, where we will integrate this vehicle with its tank and booster. The vehicle will roll in and connect to a lifting sling at the forward and aft attach points, and they'll lift that vehicle 16 stories up and then thread it like a needle down through the access platforms. You can see how tight the access platforms are around the orbiter once we lower it down into the cell. Here the technicians are connecting the bipod struts, the forward attached struts, to the orbiter, and off we go out to the pad on the crawler transporter, moving about 0.8 of a mile an hour to take the 3-mile journey out to the launch pad. About 12.5 million pounds on top of the crawler as we head out there. And you see the rotating service structure back away from the vehicle. And here we are at the launch pad, and we're poised for a Thursday evening liftoff. And that's all I have, Bruce. And
great, Steve. Thank you very much. Appreciate that. Glenn with a payload update.
Good morning. For ISS 14 UF2, this is the 14th ISS mission, and STS-111 carries the MPLM Leonardo, which is the 3rd flight of Leonardo and the 5th MPLM flight for the MPLM program. It's the fullest MPLM flight to date, 15 racks out of a 16 rack capability, consisting of 8 resupply return racks, 5 resupply storage platforms, 1 express rack 3, and the first European facility class rack to be ever flown to station, called the Microgravity Science Glove Box. The cargo includes ISS spare parts, hardware, crew equipment, consumables, and various experiments such as advanced astroculture, biotechnology cell science storage, crew healthcare systems, human research facility, microencapsulation, electrostatic processing system, pore formation and mobility investigation, solidification using a baffle in sealed ampoules, investigation the structure of paramagnetic aggregates from colloidal emulsions, space acceleration measurement system. MPLM weighs approximately 22,200 pounds. And another prime payload up on this mission is the Canadian Mobile Base System. MBS will be attached on top of the mobile transporter currently on orbit from mission 8A, STS-110, and then the station arm will be attached to the MBS to form a mobile arm system that can translate across the span of the SDR truss for subsequent construction of station. MBS weighs just over 3,200 pounds. Another payload we have on board is the Space Station Remote Manipulator System Wrist Roll Joint, which is a launch and need on-orbit replacement unit. The first true launch and need ORU to be flown to station. The launch and need ORU wrist joint will replace the current unit on orbit to reestablish dual redundancy capability on the arm. This ORU and its FSE weighs just over 540 pounds. The PDGF will be installed on the P6 truss for subsequent grappling activities to relocate P6 in the future. And the last piece of payload is the service module debris panel, which is temporarily stored on PMA-1 until need with the Russian service module for outfitting. Mission priorities are to rotate Expedition Crew 4 with Expedition 5 crew, berth MPLM to Node 1 and transfer its hardware, install and check out MBS, return ISS hardware, and transfer the service module debris panel and a P6 power data and grapple fixture. And we will remove and replace the launch and need wrist joint with the one in orbit currently. We also have 5 mid-decks to stow IL-24 tomorrow. It's the PCGS test. It's the Protein Crystal Growth Single Locker Thermal Enclosure System. The zeolite crystal growth, biotechnology cell science storage, and commercial refrigerator incubation module for the biocell storage, science storage experiment. Everything in MPLM has been checked out. The MPLM, the vehicle itself, is performing nominally, and as of Friday, the final walk-down and inspection was completed and the payload bay doors were closed. And that's all I have to report at this point.
Great, Glenn. Thank you very much. And now with our update on the weather, Kathy Winters.
Good morning. Well, we are expecting some weather for launch day. Winds are going to be from the west, gradient flow from the west on launch day, and then we are going to get our sea breeze that kicks in from the east, and there's plenty of moisture in the atmosphere, so we're going to get some rising air, and we're going to see some thunderstorms pop up as we typically do in the summertime here in Florida. Currently looking at our satellite picture, And you can see right now there's not a lot of weather affecting us. We do expect to see some thunderstorms form today, but not over the east coast of Florida. It would be more along the central and west coast of Florida, and we should be spared of thunderstorms in our area for the pad operations until launch day. Getting into our tanking forecast, weather's looking very good for that. There's just, I put a very slight chance of thunderstorms down just because we do have a trough to the north, but generally it looks very good for tanking, only looking at a 10% chance of having any thunderstorms affect tanking. And then for our launch forecast, main concern is the thunderstorm activity that we're going to be seeing, going with a 60% chance, 60% probability of violating constraints here at KSC. And then the SRB recovery forecast looks good. There could be some thunderstorms well off to the north, but generally weather's looking good with seas just at 4 to 5 feet. And for the Northrop Field and Edwards, everything is looking good for these sites. And for the TAL sites, weather's also looking good on the launch day. If we do happen to delay 24 hours, again, still looking for the same thunderstorm activity on that day. The low-level flow is generally a little bit stronger, could bring those thunderstorms a little bit closer to us when they form, and that's why we want a little bit worse conditions for that day. So we want the 70% chance of prohibiting launch on that day. And for the CONUS sites, looking at some thunderstorms over the mountains around Northrop and also Edwards, some showers within 20 nautical miles. And finally, for the TAL sites, there is a chance of showers within 20 at Maroon. And finally, with a 48-hour delay, still, again, thunderstorms here at KSC and a 70% chance of weather prohibiting launch. And for the CONUS sites, again, those thunderstorms over the mountains at Northrop Field, but everything looking good at Edwards. And at Zaragoza, also looking for a chance of showers within 20. So our main concern for launch is the thunderstorm activity we're going to be seeing, and that's all I have.
Okay, thank you, Kathy. And let's open it up for questions, starting with Peter right here.
Peter King with CBS News Radio. And this question is for you, Steve. In your best layman's terms, can you explain the job of the valve that was replaced over the weekend, please?
Well, beginning on Thursday, I guess we were running through our normal aft confidence checks, which are the electronic checks we do after we put the aft close the aft for flight and put the doors on. We sensed that the heaters were acting a little bit funny on the water spray boiler, which indicated that we may have water in the boiler core, and then thus pointed to one of the two valves that sprays water over the cooling coils inside that boiler was leaking. So we went and investigated which valve was leaking first, and then we had to assess whether or not we could actually get access to that valve in the vertical position out at the launch pad. We had the vendor, Hamilton Sundstrand, come down and evaluate that work, and they agreed that they could get it in the vertical, so we proceeded to build up a couple of special tools to get in there and take the flanged valve out of there. We went through a process of reinstalling the valve, flushing through the valve, doing a series of leak and functional checks, and then went into a 24-hour decay check on the valve and the boiler to verify there was no additional leakage before we closed the aft for flight.
And about how big is that piece of equipment, that valve?
I haven't actually seen the valve. I would assume it's about the size of a softball.
Great, thanks. Brad, you had a question?
Brad Liston from Reuters for Kathy. One thing I've never been clear on is that the forecast, the 60%, the 70%, is that for the 4-hour window that the public is given, or is that for the actual 5-minute or 10-minute launch window?
It's for the launch window, not the 4-hour window, but the actual launch window.
Okay. Kelly?
Kelly Young, Florida Today for Steve. Was there ever a concern at all that might not be able to have enough time to change out this valve?
Well, certainly this was non-standard work that we had not performed before in the vertical, and therefore did not have a good understanding or historical database that would say, here's how long it takes to change the valve. So we went into it with a little unknowns. We laid out the schedule as best we could, and then we were waiting to see throughout the weekend whether there was any unforeseen occurrences that we would have to compensate for. And in fact, we held pretty true to the timeline. That speaks to the guys who put those schedules together, and also the folks helping to contribute with the estimates to the work. So it did track pretty closely to the schedule we laid out. We were just waiting to see if, in fact, the valve continued to leak or we had any additional problems. And that was not the case. And here we are in a posture to pick up countdown like we did, and we're off and running.
Okay. Mark?
Mark Carew from the Houston Chronicle. Just to follow up on the valve question, my question is for Steve Altimus. What's the impact of that sort of leak operationally? Does it allow the hydraulic unit to heat up, or is it more of a long-term problem with the mechanism?
Well, what happens is when you get significant leakage through that valve, you ended up in essence plugging the line that sprays coolant water over the APU lube oil coil. So in effect, you would degrade or not be able to use APU3 in your anytime you need hydraulics or auxiliary power units. So you would have an overheating of the APU lube oil because the spray valve wasn't functioning properly.
Okay, thank you. And then I have a question for Kathy Winter. Could you explain the sort of big picture weather system that's affecting the forecast for the launch day and the 2 days after? What's kind of the big picture that's driving this?
There's mainly a trough to the north, which basically is bringing our winds to be from the southwest and the west on those 3 days. So, and then there's a lot of moisture in the atmosphere, and with that, that's how we end up getting our thunderstorms. But the trough to the north is definitely going to cause those winds to be from the west-southwest, generally, the flow. And then we get our sea breeze that gives us the southeasterly winds at the launch pad.
Gather from what you're saying, at least in the 3 days you're forecasting, there's not enough force to kind of push all that out of here. What can you talk? I'm sorry to get so technical, but what's causing? Is this a seasonal thing, or what's causing it to just kind of hang there?
Well, there's no upper level jet max, if you will, that's going to come in and push that trough out. So it just is going to kind of hang in the area and to stay in the northern part of Florida. So there's nothing really. Usually we get an upper level feature that would come through, like a jet maximum that would come through and push that trough out. But there's nothing like that happening. It's not really a big high pressure area moving down from the north or anything like that. It's not really like a wintertime system. It's more of a wave, if you will, like we see in the summertime.
You forecast for 3 days there. Is there anything that's going to change right behind that you see now, or if you had gone out for a couple more days, would that pattern still be the same?
It would take a couple more days, and then the pattern basically we get drier air in, and that's what changes it. It's not really the movement of that trough, it's more the air drying out that changes the chance of getting those thunderstorms. It decreases them by about Monday.
Okay, any other questions? Okay, Brad?
Brad Liston, Reuters for Steve. I hope I didn't miss this, but do you have any insights into what caused the leak in the valve, and are there any concerns about the other valves?
Well, actually, there is a theory that says there was some contamination that built up on the valve seat, thus not permitting the valve to close all the way, and you get some leakage through the valve. There's an analysis occurring right now as the valve was shipped back to Hamilton-Sundstrand for teardown. And we're going to look inside that valve and see exactly the mechanism that caused the failure. So I think that's where we're at right now, and I'll reserve any more further comment until we hear back from the vendor.
Okay, Peter?
Peter King, CBS News Radio. This is for Glenn. I'm still trying to get a feel for the size of that roll wrist joint, and I'm wondering if you have any dimensions other than the 540-pound number you gave us earlier.
The wrist joint is maybe about a 2 by 2 by 2 wrist joint size.
Okay, thank you. One last call for questions. Okay.
we're back. It's great to be here, and it's great to make the transition from the training phase of this flight and the preparation phase to the operational phase. We understand the vehicle's coming together. The launch director tells us there's a few things to go and maybe a tight squeeze to make it on the 30th, but we're optimistic and we're looking forward to it. Glad to be in Florida.
It's a pleasure to be here. I feel like I've been part of Team NASA now for about 6 years, and now it's a real pleasure to come together and be a part of Team STS-111. And it's going to be a real honor and pleasure to bring up Expedition 5 and bring down Expedition 4. So looking forward to seeing you all in a few weeks.
Yeah, things are becoming more and more real every day, and I'm looking forward to that flight. We've got 3 EVAs to do, and I'm sure it's going to be extremely exciting.
Well, it sure is a pleasure to be back here in Florida, getting ready to go fly, and looks like a lot of people have done a lot of hard work to get us get the vehicle ready to go, and we are ready to go. So we're looking forward to this mission and completing all of the objectives that are lined up for us. Thank you.
I'm happy to be here again, and I'm so happy to have flight on ISS on Shuttle Endeavour with STS-11 crew. Thank you.
Thank you. Well, Expedition 5 is ready to go up and take over for Expedition 4. We're really looking forward to it, and see you in a few months.
It's very nice to be here again to me. It's very nice to fly and to work on board the station. And it's nice twice because I fly with very remarkable and clever and attentive guys like this one, and it's besides there are very experienced astronaut and cosmonaut. I guess you guess you know whom I speak about. And I'm very happy to fly with crew, with team. Thank you.
Good afternoon and welcome to our STS-111 pre-launch press conference. We have as our participants today Ron Dittemore, Shuttle Program Manager, Bill Gerstenmaier, Deputy International Space Station Program Manager, Alain Delouf from the French agency as the System Studies and Development, Dave King, Director of Shuttle Processing, and Lieutenant Tom Crenshaw, our Launch Weather Officer. And we'll begin our briefing today with statements from each of these, beginning with Mr. Dittemore.
Well, I'll be brief today. We had a good L-2 meeting, and all things are go for us to proceed to tanking and launch operations on Thursday. The ship's in fine shape, the crew's in great shape. We may end up dodging a few thunderstorms and weather on Thursday, but I'll let our weather experts talk about that. But from my perspective, looks great, and we're ready to proceed.
Okay, thank you, Ron. Bill?
It's great to be here again. The space station is ready for the shuttle to come up and dock. We're ready for the crew exchange. The payloads are all successfully placed in the MPLM. It's ready to go. All other activities proceeding on track and on plan, and we're ready to go, and we're ready to support the launch.
Okay, thank you, Bill. And Alan, a statement from you, please, sir.
Oh yes, perhaps I can give some words about this flight for France. It's a very important event. This is the 16th flight of a French astronaut and the 8th with NASA. So it's a very well balanced cooperation between Russia and now and NASA. For us, it's very important also. Probably this is from the beginning of space cooperation between France and United States. This is probably the most active period of cooperation, because we have recently launched JSON 1, and of last year we are presently setting up a new program, JSON 2, for the follow-on of this mission. We have also a discussion very well advanced in the field of cooperation for Mars exploration and also for Earth science. So it's, but in addition to the technical and scientific cooperation, human flights have a special perfume due to the fact that it's a human cooperation in space. So I think it's a very nice place for us. I can say also that for Philippe, this is his first flight. He has been training since 1996, so, for 6 years, very hard. For him, this is the first mission, and he's very lucky due to the fact that he has 3 spacewalks to be performed during his flight. So I think it's very marvelous.
Okay, thank you, sir. And now Dave King.
Good afternoon. We're in a pretty standard countdown today. We did have a little bit of an eventful weekend. We had planned on having off and found a technical problem with the water spray boiler. We had to change a water valve out over the weekend. All that work's been accomplished. Retest was successful, and we picked up the count Monday evening, and we're doing just fine. Everything is pretty much on the timeline today, and we expect things to continue that way for the next couple of days, and we're looking very much forward to Thursday evening.
Okay, Dave, thank you. And now with the weather update, Tom Crenshaw.
Good afternoon. What we're expecting is a low-pressure system that's sitting off the coast of Florida right now to move to the north. We also have a low-pressure system moving through the Great Lakes and up into the northeast of the United States for the launch day. That being said, for tanking, we expect some scattered low clouds, winds from the southwest, very light, 5 to 8 knots, with just a slight chance of thunderstorm to affect, so only 10% chance of violating our constraints for tanking. For the operational forecast, we're looking at some scattered low and mid cloud and some scattered possibly broken high cloud with the winds from the east, 10 to 15 knots, with a chance of thunderstorms in the vicinity. That being said, the chance of violating our launch constraints are 60% at this time. For the solid rocket booster recovery, we're looking at scattered low cloud, broken high cloud, winds out of the north-northwest, 338, peak 12 knots, with a chance of some isolated thunderstorms. Looking at only 4 to 5 foot seas out there right now, so looking good. In the event that we do have to delay 24 hours, like I said, the low pressure system moving into the southeast is going to increase our chances of thunderstorms. Right now we're looking at scattered low cloud and broken mid to high cloud, with winds remaining from the east, 10 to 15 knots, with a thunderstorms in the vicinity being our main concern. 70% chance of violating is what we're going for right now. And for the 48-hour delay point, similar to the 24-hour point, scattered low, broken mid to high cloud, and winds shifting around to the west, 10 to 15 knots, with thunderstorms in the vicinity. 70% chance of violating constraints for the 48-hour delay point as well. For the CONUS landing sites, day 1 looks good. Excuse me, Edwards, just a scattered high cloud, winds from the southwest, 13 to 20 knots. White Sands, scattered mid and high cloud with the winds from the east, 10 to 15 knots. For day 2, Edwards, again, picking up some more low and mid clouds, broken high cloud, winds from the southwest at 6 to 10 knots, and a slight chance of showers within 30 nautical miles as well. For White Sands, again, similar clouds, some scattered mid and upper clouds with winds from the east at 10 to 15 knots, and the chance of thunderstorms within 30 nautical miles over the mountains. For the day 3 forecast, Edwards looks good at scattered mid and high cloud, winds from the west, southwest, 70 to 25 knots, and white sands just few at 6,000, broken 12, broken 25, winds from the southwest. There is still that chance of thunderstorms remaining over the mountains within 30 nautical miles. For the TAL sites, day 1, benign weather, Zaragoza, Morone, and Ben Guerir. No concerns at this time, just some scattered mid and high clouds for all sites. Again, for day 2, similar weather, no real concerns, either just scattered high cloud as well. On the day 3 forecast for Zaragoza, some scattered low and mid cloud and broken high cloud with winds from the east at 7 to 11 knots with a slight chance of showers within 20. For Morone, some scattered clouds, winds variable with a slight chance of showers within 20. So the TAL site's looking a lot better than the launch site.
Okay, Lieutenant. All right, we'll open it up for questions. Let's start over here. Well, let's take Stephen right there since he's handy.
Stephen Young with SpaceflightNow.com. I think for Ron, you seem to be quite tight on cryo on this mission. I'm wondering what the reason for that is.
Well, usually it is because we load the tanks full, and for what all the activities we have on orbit, we're consuming a lot of power, which means we don't have a lot of margin left as far as consumables to go extra days. In many cases, just depending on the content of the mission and the power usage, that's just the way the cookie crumbles. And it turns out this case, we're just very tight.
And on the weather, could you give us a little more detail when you expect these thunderstorms to start being a factor and when they might die out?
As far as being a factor, we'd expect them to be a factor much of the launch window. They would start out mid-morning to late morning and then move inland, and we would be affected by the anvil cloud being pushed over us by the upper level winds for much of the day. So.
Okay, thank you. Let's move down here. Marcia?
Marcia Dunn, Associated Press, for either Ron or Dave. I was just wondering if you could look ahead and give us your best estimate for Columbia's launch date.
Well, I would say, and Dave, you had a few things after this. We have a tight schedule to meet our targeted launch date in July. We've agreed to meet again in mid-June timeframe, assess how we've been doing on our schedule, the accomplishments, what content remains, and make a judgment then on how much margin we have to meet that targeted launch date. Dave, do you have anything?
Yeah, the only thing I have to say in addition is the process has been going very well on the vehicle. We do have a lot to do. It is a very tight flow, and we need to see how we do for a couple more weeks before we pick a launch date. It's going to be sometime before we are able to really tell with any fidelity. But things are going very well, and we're pretty much on schedule as of now. We're going to be looking at that in a lot more detail in the next couple of weeks. We get through some critical path operations in the next couple of weeks, so it'll be tell for us.
And 19th is still?
That's still our target.
Okay. Small chance you can make it, though. I mean, it's just...
that's what we're still holding right now, Marcia, on paper.
Okay, thanks.
Okay, Stephanie?
Stefan Fledan, Public Mechanics, for Lieutenant Crenshaw. When do you expect the weather to clear in order for the shuttle to take off?
For the day of launch, we would expect the weather to actually start improving later afternoon, but then we have...
I mean, later in the week or earlier next week.
At this point, it looks like at least the third day it looks a little bit better. I don't have the guidance for those hours, that third or fourth day on, but at this point, if I remember correctly, it is improving somewhat after the third day.
Okay. And for Mr. Meyer, what is the drop dead date that you would have to bring down the crew from the station via the Soyuz?
We really don't have a constraint for that. We have an extended amount of time we can stay on orbit. We continually assess the crew's health. We've got consumables on board that are no constraint to us, so we just continue to evaluate and just stay where we are. So we're not under any constraint or any pressure at all to launch and return the crew or return them on Soyuz. So we've got on the order of multiple weeks to months.
Okay, thank you. Phil?
So, Jonathan, for Ron Dittemore, for the July mission, are there any additional safety or security concerns because of the fact that there's an Israeli payload specialist on board? Are you going to be doing anything differently than what you're doing for this mission?
I think I should repeat what I've told you in the past. Security is a sensitive issue to us. We're taking all the precautions we think that are absolutely necessary, and I feel very comfortable with those precautions that we have in place.
Okay, thank you. James?
It's Jim Banky, Space.com. You don't need Phil Chin to tell you that historically the agency has often planned things weeks, months, years in advance. So I guess I'm asking Ron and maybe Dave to talk a little bit about the whole wrist roll joint addition of that repair to this flow or to this mission, throwing it on the schedule at the last minute, getting it all together in terms of crew training, the impact on station bill, and certainly processing at Kennedy. Could you all talk a little bit about how that all came about? And I may have a follow-up if I don't get the quote I want.
Sure. Let me, Ron, if you don't mind, I'll go ahead. Let me tell you from a station standpoint, the way we looked at this. We had the problem with the arm and the wrist joint. We looked at the activities that were coming up on the remaining flights. You know, for example, we're going to install the S1 truss, the P1 truss, etc. All those require a functional arm. We looked at the current arm configuration and made sure that the arm could operate in the current mode for all those flights. So we didn't consider the joint change-out a mandatory activity that had to occur before those flights. So we got together and we looked at the risk of trading a joint out. Could we get it physically to Florida? Could we get a joint to checked out? Could we get it installed in the cargo bay? Could we get the right wiring there? Could we get it to orbit? Could we get the crew trained, etc.? We went through each one of those things very methodically, and we traded those against the risk of a compressed timeline to get the activity done. After we looked at all that, it was determined that from a failure analysis standpoint, it would be good to get the joint back so we can get it on the ground and take a look at the joint and see what's wrong with it and see if there might be other concerns with other joints or anything else of a generic nature that might change the way we plan for future activities. So we decided to go ahead and bring the joint back. But we only did that after we reviewed with the entire team. Was there enough training time to get this done? Was there enough time to go in the pool? Was there enough time to work through the training tasks associated with it? Was the hardware available? Could we get all the procedures done and get everything done in a very methodical manner? So even though it's a compressed timeline compared to what we normally do, it was still well within our bounds. We went into it with our heads up. We went through each item, analyzed it, made sure it was okay, and we're ready to go fly. And this is our first launch on need, and it's really a tribute to the team to watch how this launch on need team came together, pulled this all together, and made sure that the crew was ready, the ground control teams were ready to execute, and we've got a procedure that's safe to go do that'll put our arm back in full-up configuration.
Follow-up, John?
Yeah, as a matter of fact, when did you guys, NASA, learn to be able to do this? At what point did you think you got the experience where you can throw these things, and I'm going to use the term, throw these things together at the last minute, where you feel comfortable doing that, sort of break out of your mold of months and years of planning?
Well, I would say that years ago we recognized that if we're going to operate, maintain, and sustain a space station, that we were going to have days like what Bill just described. And they're going to vary in complexity. Some are going to be large and very challenging and complex. It's going to take a longer period of time to understand them. But there is a category that's somewhat well defined, and we recognize that that category we're going to have to be able to be very flexible and quick to respond. And I think this is a good example of that type of category. It was fairly well defined. We thought about it. We had a replacement unit on the shelf, Bill had, and it's a credit to the team that they were prepared enough that they can account for something like this in roughly a 6 weeks period of time. Not only do the engineering, do the training by the crew, adjust whatever procedures are necessary, but also by our processing folks, which Dave ought to talk about, in order to look at just what we had to do, lay it out, and then accomplish that task. So the positive thing on this event was the flexibility that we knew we were going to have, and this just shows that we made a lot of progress towards that end. And we haven't reached the right quote yet, so David.
I'll let you know that.
From a vehicle processing perspective, it wasn't that large of an impact to us. It was probably more of an impact from a station processing perspective of getting the joint here and getting it packaged and ready to go in the vehicle. But when you stop and think about the complexity of this station and our ability to be able to react to little things that come up like this, it's pretty incredible. And your question is well founded. Is how do you react that quickly? And I, as these folks have said, I think it's a real credit to the team to be able to pull all that together in a very short period of time and to pull it off. This was not a simple, easy thing to go do, although it was fairly well defined, as Ron said. It was not simple and straightforward, and so we're looking forward to getting this problem behind us.
We have a series of equipment that's defined as launch on need. So for that equipment, we have already put in place basic procedures. We have built flight support equipment to launch it in the shuttle. We've analyzed at a top level what the big picture typical long lead items are, and we've worked all those long lead items off ahead of time. So we happened to have a failure in the launch on need component that had all those long lead items worked out, and we were ready to go execute. The team rose to this situation and did a great job of putting it all together.
Okay, great. Thank you. Mike?
Mike Cabbage with the Orlando Sentinel for Mr. Gerstenmaier. You touched on this a moment ago in your answer to Jim's question, but could you elaborate a bit on the importance of the station arm to future station assembly?
I mean, it's obviously a critical component. It's going to be used to install all the remaining truss elements that are coming up the rest of this year. So it's key to building station. Without the arm, we could not continue to build station. So the arm needs to be there, needs to be functioning.
Okay, Mark.
Thanks, Mark Carruth from the Houston Chronicle. I think it's for Ron Dittemore or Dave King. I just wondered on Columbia, what's the pressing item on refurbishment, if it was the radiator, or if you solved all that problem, or it's the processing of the payloads? You got that one?
I'm not sure I understand your question, Mark.
Yeah, I was looking ahead to the
critical path.
107 and what's sort of the long pole in the tent.
Well, we had to take down some Freon loops this time. One was for the contamination that we had on the last flight, and the other reason was a cold plate that we had to change out. When you have Freon loops down, you have power down on the vehicle, and that put us behind the power curve for a normal flow. So we're trying to catch up with all the power-up testing that needs to be completed. And all the mid-body closeouts that need to be completed to be able to get the payload installed as we did last week. And it's a basic flow of getting all the hardware installed in the vehicle and get the power-up testing. And when you lose a couple of weeks to change out the Freon system hardware, that puts you behind the power curve a little bit.
Todd?
Todd Halverson of New York Times for Bill Gerstenmaier. Could you discuss the mobile base system and how it will play in the remainder of station assembly, and what the upshot would be if that component could not be installed properly?
Okay, the mobile base system is essentially the interface between the mobile transporter, that's the rail car thing, electric rail car that runs up and down the truss, and the shuttle, or in the station arm, the SSRMS. So it's the interface between that mobile transporter and the SSRMS. And it also includes multiple payload data grapple fixtures on it. It also has a spare latching end effector, we call it a POA, to place payloads on. And that's another device that we can attach a payload to and then run it up and down the truss. So in terms of criticality, this mobile base system needs to be installed because the next installation task, the S1 truss, the arm will be based on the mobile transporter, sitting on top of the mobile base system, then reach into the cargo bay to grab that truss element and then attach it to the S0 truss that's on orbit today. So this mobile base system is the next critical component that has to be there to allow us to go grab the next truss pieces that go to station. So just as I described before, the arm was critical. Well, then you could think of this as the base to the arm, and this is just as critical as the arm for those other operations. So it's kind of the future attach point for the arm, future attach point for space station payloads, and it's that critical base system.
And just to follow for you, the crew on orbit now, if if the shuttle lands on time, that homebound crew will, I believe, tie a record for the longest U.S. space flight, and 188 days. And I'm wondering if that is going to be a trend in the future where we start to see longer stays on orbit as a result of budget constraints and perhaps fewer shuttle flights to and from the station.
You know, our basic guidelines are we try to schedule the increment durations to be anywhere between 120 and 180 days, and that's just kind of for planning purposes. We tend to be a little bit on the short side, somewhere in the 130, 140, 150 kind of number of days, and that's in case we have some problem either on the ground or some other thing that's caused us to slip into 180-day. But there's nothing magic about the 180-day time frame. It's just where our experience base is. What we want to do is we want to gain some information of the varying increment lengths, understand physiologically what happens to the human on orbit and in space, make sure we're doing the right prescriptions and the right protocols for exercise to make sure our crews are ready to stay for those durations. And we'll look at lengthening the duration as we go through. But right now we're going to stay with the 120 to 180 for a period of time. We'll look in the future and see if it's more appropriate to move to 180. But this will be a good data point for us to see how crews do over this period with the exercise equipment they have on board station and the countermeasures that we've been doing. So this will be a good piece of data. We'll take this data, analyze it, and then we'll decide where we want to go with future crews. But for now, we'll stay with the 120 to 180 day guidelines.
Thank you. Vic?
Vic Rapner from ABC. To follow up on that, how fatigued do you think this crew is from the time that they're up there, and how do you evaluate their fatigue, particularly their emotional fatigue, in the aftermath of the shutdown last week?
I think we have a team of flight surgeons and folks that talk to the crew all the time. We have various like support activities for them. You know, we bring family members in and do two-way video conferences. So we look at all that. We assess the overall crew health. We look at the performance of how they're doing in basic tasks and what's going on. And this crew has been just outstanding. I mean, they have a great attitude. They are ready to go. They've been busy, you know, packing and getting things ready on station for the shuttle arrival. They're doing some SSRMS checkouts today of the arm, getting it ready, make sure it's operating and functioning. And their performance has just been outstanding. So we just kind of assess them over the increment and see if we see anything that's of interest. We haven't seen anything. This crew is doing outstanding, and they're in very, very good shape.
You don't see signs of fatigue, fall off in performance?
We don't see any, no.
Okay, thank you. Peter?
Peter King with CBS News, and I guess this is for Ron or Dave, but it may be more of a Dave question. Much of the infrastructure here at KSC is dating back to the 60s or 70s, things from computers to wiring and piping and that sort of thing. Recently we had a vent line rupture before one launch. The crawler broke down a few months ago, and there was a recent story that you guys are looking for spare computer parts on eBay. I'm just wondering about your concerns about some of the equipment that may be getting older but not necessarily getting better right now.
It's a lot of equipment here at Kennedy Space Center that's been in action for a lot of years. We're continually evaluating where we stand with regard to that. We don't believe we have any short-term safety issues associated with infrastructure here at Kennedy because we're mitigating those on a day-to-day basis. We're evaluating those and taking care of the things that absolutely need to be done. However, with the budget situation that we've had over the past few years, we have not been able to do much of the long-term work that we would like to do on some of the facilities around here. And when you have facilities that are around 40 years old, that starts to become an issue for you. So we are watching that very close. We have a lot of projects on the horizon. We're prioritizing those projects from a program perspective, both here at Kennedy and at the other sites where we have lots of infrastructure, and we do have that all over. We're taking care of those as we can, and we've got a plan to move forward on that.
Dave, could you give me an example or two of things that would be absolute priorities and an example or two of things that might be toward the bottom of the list as you get this done?
Without getting a lot of specifics about that, Peter, I guess, you know, we have crawler transporters that we need to refurbish. We've got some equipment on there that's very, very old, and we're in the process of upgrading those. We are changing out some of the underground cabling little by little as we can. We have quite a few issues surrounding corrosion at the pads and at the VAB that we are continually working on a day-to-day basis, trying to get periods where we can go in and change steel out. So those are some of the examples of things that we're doing. There's a long list of things that we would like to do, and some of the things that we're able to defer right now are some of the longer lead items that we don't, you know, we need to get to them within a certain period of time, but it's not an imminent issue for us. So that gives you an example of some of the things that we are doing anyway.
Brad, do you have a question?
Brad Liston, Reuters, for Ron Dittemore. When you express your satisfaction with security as it is now, are you saying that you would like to see this become the status quo with secret countdowns and hidden astronauts and all that, or are you hoping that you can reach a place where you're more accommodating and at the same time still as secure?
I look at it this way. I have a very precious asset. This is the only human space transportation system in the United States. I have 4 orbiters. That's all there is. And I want to preserve and protect those assets to the best of our ability. And I think that pertains not only to this environment, but to the environment in the future. And I think that we take a lot of pride, this country takes a lot of pride in the space program, and I think it's to all our benefits to keep it secure and protect those assets to the best of our ability. On the flip side, sure, I would like to have more opportunity for people to view, to see, to experience the human space-like nature that we see on an everyday basis. It's an incredible opportunity to work with the talented people in this business. And I would like more people to see those talents, to see the hardware that they build up close and personal. It's amazing what has been accomplished, what has been built, and what is being operated. And it's very difficult for the person in Wisconsin or Washington State or Nevada to really get a feeling for this hardware, the magnitude of it, how huge it is, and the enormous power it takes to put humans in space. I'd like to have every one of those folks have the opportunity to get more up close and personal, to see what this country has accomplished, to see what they have accomplished because of their tax dollars.
Okay, thank you. Other questions? Let's bring it up here. Jay?
Jay Barbary with NBC. For Ron, I want to go back and revisit the question that Marcia had. If you launch STS-111 on the 19th, you'll be returning 18 days before the STS-112 mission. Now, are you going to be able to follow through on that if you can get up there, and if it's likely you're going to move from the 19th a few days, how much will you move the follow-on to for the rest of the year, 12 and 13?
Well, you know, talk to my friend Bill here. We have talked, and we would certainly like to get 112 and 113 off in the approximate time frame. 113 really has kind of a hard point on it about October 6th. It starts running into some physical constraints when we actually could launch. And if we don't meet October 6th plus a few days, it could result in a fairly significant jump into November. But we do have good margin on 112 and 113. We could slip 107 a few days, not impact that schedule at all. I think it's all going to work out just fine. I don't see anything on the horizon that would lead me to believe that I can't do the manifest that I have on paper today.
Because the 107 is not a space station flight. You can still land within 18 days and still make 112 okay?
Yeah, in fact, 18 gives us sufficient margin. If I move 107 to the right a few days, I might look at 112 to make sure I have the right spacing.
And I look at that more from a workforce point of view to make sure my team is rested. I look at it from a technical point of view to make sure we've had enough time to analyze the flight, to make sure I haven't experienced an anomaly that would cause me some concern. So I don't like to plan flights any closer than 14 days. I can do it even closer than that, but prudence says I ought to be around 14 days or greater. Now it's looking at 18. That makes me feel pretty good. I have a few days of margin there that I can deal with 107 and still get 112 and 113 off as planned.
Thank you, Ron.
All right, Kelly, second row.
Kelly Young, Florida Today for Bill Gerstenmaier. I was wondering if Russia had any sort of deadline for filling that November Soyuz seat.
I don't believe there's any deadline associated with that right now.
Okay, let's bring it up to Marcia here.
Marcia Dunn, Associated Press for Dave. What was the underlying reason for the problems with the Freon loop in Colombia? Was it the welding that had undergone? I mean, what did you find that caused the problem to begin with?
The Freon loop during the last flight experienced we had some brazing material that got caught in an orifice, basically. There was a leftover remnant of the brazed material that got stuck in one of the orifices in one of the aft loops on the Freon system, which degraded the flow to that portion of the Freon loop. We do quite an extensive amount of decontamination after you have a large amount of brazing that occurs, like we did on 102 last flow. And we look at all the low areas. We do a lot of x-raying to verify that there's none in there, but we obviously missed one.
It was just in one location?
One location, one little piece of metal. We, from the data that we got from the folks at Johnson, looking at the signature of the flow rates on the vehicle, we went into the aft, and within a day of getting in the aft, took an x-ray of this orifice because that's where we suspected, and it was clear that there was a piece of contamination in that orifice.
Okay, thank you. Dan?
Dan Billow from WESH TV. This question's for the representative from the French Space Agency. I'd like to know how you feel about the U.S. posture on assembling the space station right now, which posture is that you know, they're going to assemble the United States parts and let the European and Japanese and the parts built by the rest of the world kind of be on hold and in limbo. Is that satisfactory to you?
From a technical point of view, I think it's a demonstration of what NASA is able to do, so it's marvelous. But we have some concern about the funding of the things, and to the fact that probably we'll stay with a station with only 3 astronauts on board for a long time. So there are at the present time a number of discussions between NASA and ESA and other representatives in this cooperation. We'll try to find a solution for this thing. Different options are considered, but for the present time we have not yet answers, due to the fact that the main problem is the U.S. funding part, of course.
And I would add, from a technical standpoint, if you look at the physical configuration, Node 2 needs to be there before you can attach any of the international partners. So if you look at the assembly sequence we've got laid out, even though the U.S. elements come first, that's because we're laying the basic infrastructure in place that allows attachment of the node and then allows the international partners to be added. So it's not that we're biased towards flying our pieces first. Our pieces happen to be a portion of the infrastructure that needs to be there to support those modules when they come up.
Okay, thank you. Other questions? Okay, let's come down here to Phil.
So, Northern Ron Ditmore. Given the fact that you are using what would have been an extension day instead for EVA3 and SSR joints change out, and so you got the very tight file margins, June 3rd is a flight before only launch day. Would you even try to launch the day assuming that the weather was good on the next day, or would you just not try, assuming that we can't get off before then?
Yeah, I think we're in the posture that we're going to launch on flight day 3. If we launch on a flight day 4, it essentially takes a day out of your docked mission, which would be a significant impact to our plan. So since we have control over when we launch, I think we'll choose the best time that maximizes the time available to do the job that we have planned.
Mm-hmm. And a curiosity item, I was impressed with how rapidly everybody got together with the SSRMS joint replacement. But why the choice of putting it in the cargo bay as an unpressurized item uphill as opposed to either putting it in some kind of structure that could fit into the shuttle airlock or even in the empty rack in the MPLM, and that way it'd be a lot easier to carry uphill?
I guess it goes back to the original discussion we had. We've designed this FSE carrier to hold it out in the cargo bay, and it has certain attach points where it attaches with a known configuration out in the cargo bay. That was much better understood than if we would have tried to put it in the middeck. To put it in the middeck, we would have had to build a unique piece of GSE to hold it in the middeck, and it turns out that would have been about at the load limit carrying capability of the middeck. So when we did those trades, it was clear we were going to go back to the plan we had already worked. We had the FSE built, we had the gas beam already sized, we knew where we wanted to go put it in the cargo bay, so that's where we wanted to go fly it to ensure that the joint gets to orbit in a good, pristine configuration.
Okay, Jim. JimBankySpace.com, following up on Mr. King's infrastructure question for Mr. King up here. Could you review what you've done since the last launch in terms of that, the gaseous hydrogen vent line? What have you gone to go look at that plumbing, instrument it, repair it, replace it, make sure it won't happen again?
Yeah, Jim, what we have done, obviously that was on another mobile launcher platform. So what we've done on this particular launcher platform is go back and we did some loads analysis to see, first of all, we did some failure analysis on the one that failed and the loads analysis associated with that. And what we determined to be the causal failure was overload, tensile overload. When we got to looking at the weld, it was a very poor weld. The weld was probably 40 years old from the Apollo era. So we took a look at the mobile launcher that we have this vehicle on today. We did loads analysis. We looked at the areas that would carry the most load. We did find that the peak load on any of this system was the launch load. So we went back and calculated the peak load on those particular lines. We did some inspections of all of those. We also attributed part of the failure to an incorrect filler material that was used on the original weld 40 years ago. So we went back and verified where we had the incorrect filler material as well. So we did failure analysis, we did some non-destructive evaluation to find out what we really had on the mobile launcher at the pad, and we did some loads analysis to see where the critical pieces were and what we could do about that from a testing perspective. So we had a fairly comprehensive approach. This was not a long-term approach to dealing with this. We're still going to need to go back and do some more work in evaluating what we really have, but we think we've got a good mobile launcher platform for this particular launch, and we'll be evaluating the rest of them as they come.
Okay, and one more question.
Francis Evans, Agence France Presse for Mr. Gerstenmaier. Why don't we see any Europeans being part of residing crew of the ISS?
I'm not sure what our overall selection criteria is, excuse me, or how that works out. I'm really not the person to ask that question.
Follow-up?
No, I think since Europe is a major, one of the major financial behind the ISS, we would think maybe the public in Europe could expect to see European astronauts residing up there, and not just only Americans and Russians. And I was wondering whether there was an explanation for that.
I'm not aware of one. I'd have to go look at our memorandums of agreements and our other things in place to see if there's something in there, but I'm not aware of anything in there, but we'd have to check and look.
Okay, thanks. We're running a little long, so we'll make Stefano's question the last question.
Yes, Stefano for Mr. King. How many other welds did you find on the platform that were not up to specs? And also, Can you tell me what kind of film material was used instead of what other material?
The line material is a 6000 series aluminum material. The filler material that we've deemed as inappropriate, which does not make a good weld, is a 4000 series material. We've located where those are, done a stress analysis to verify that we're not going to exceed the tensile strength of those particular welds. So that's basically the way we went and justified where we stand today from a readiness perspective. And I'm trying to remember. We found some other welds that were not perfect. However, they were fairly, they were good examples of aluminum welding, because aluminum welding is not perfect. So what we found was some minor defects which were pretty much standard on the rest of the welds that we looked at, but we didn't find anything in the neighborhood of what we saw on this one failure that we had on the last mission.
Okay, thank you. And just a reminder, we have another countdown status briefing coming up tomorrow morning at 9 o'clock Eastern Time. We'll see you then.
Good morning. Welcome to our Launch Minus 1 Day countdown status briefing for mission STS-111. We have several briefers today joining us to give us an update on the countdown, payload, and weather. Pete Nikolenko is the NASA Test Director.
Good morning.
Glenn Chen is the STS-111 Payload Mission Manager.
Good morning.
And Kathy Winters will give us an update from the Shuttle Weather Office.
Good morning.
And we'll start with Pete before taking your questions.
Good morning. I'm pleased to be here today to provide countdown status for the next launch of the Shuttle Endeavour to the International Space Station. Countdown is continuing in progress. We're right on schedule and we're tracking no technical issues. Yesterday we completed the checkout of our onboard avionics systems, and last night we completed the servicing of our onboard fuel cell cryo storage tanks. We're currently back in the pad and are currently in work with main engine systems checks and pad closeouts, which will continue throughout today. Our other standard remaining countdown activities for today and tonight include the power up and checkout of our ground communications network, the retraction of the rotating service structure, and preparations for ET cryogenic load, which will take place tomorrow morning. Following ET load, we'll continue preparations for flight crew arrival at the pad later on Thursday. The launch period Thursday extends from 4 p.m. till 8 p.m. local. And this is a 12-day mission with end-of-mission landing scheduled here at KSC on June 11th. In summary, all of our flight and ground systems are in great shape. The launch team is focused and ready to go, and we're all looking forward to launch on Thursday.
Thanks, Pete. Glenn?
Good morning. The launch countdown activities continue to go well from a payload perspective, and we're not tracking any issues at this time. The only remaining payload activities are the loading of the mid-deck payloads into the orbiter's mid-deck. This includes hardware for the protein crystal growth experiment, the zeolite crystal growth experiment, biotechnology cell science storage experiment, and the gaseous nitrogen freezer. And we also brought a tape of video footage of the payloads before going to the pad, and if we could roll that tape, please. Here we have the MBS hardware, the Canadian mobile-based servicer coming in to KSC, and here you see a shot of the MBS. Here's a shot of the microgravity science glove box that's on board MPLM being checked out. And that's the gloves that they're donning on. That's part of the MSG hardware. Here's another view of the MBS, the mobile-based system, and its grapple fixtures. Here's the hoisting of the MBS before going to the canister for transportation to the pad. Okay, here's the station arm wrist joint launcher knee that would be replaced in orbit. Here's Franklin Chang Diaz doing a walk down and getting familiar with the hardware while it's being integrated onto its flight support equipment. Here's the upward shot of the launch and need hardware. And then here's the joint being integrated onto its support equipment. Here's a shot of the NPLM going in vertically at the pad into the orbiter. And that's the launch and need wrist joint going up to the pad for its installation into the orbiter. I think that's it. That's my report briefing for today.
Thank you, Glenn. And next we have Kathy.
Thank you. We are still concerned about thunderstorms for launch day. We do expect the sea breezes in Florida from the west and east coast to interact in the central part of the state, causing low-level convergence, which will then form thunderstorms that will then move towards the east and affect KSC late in the day. So we are concerned about thunderstorms for launch. Let's look at the satellite picture. There is a low pressure area that's located off the coast of Florida. That is expected to move gradually towards the west-northwest and weaken at the same time. So we are not expecting that to be a major factor for launch. Really, the winds are more of an issue when it comes to the sea breezes and that interaction causing the thunderstorms. For our tanking forecast, we're just looking at a very slight chance of getting some thunderstorms. Generally, we don't get the strong thunderstorms in the morning. So we are only looking at a 10% chance of violating our tanking constraints. Still looking good for tanking. For launch, we are concerned about the thunderstorms. Winds are from the southeast, and we are concerned about anvil clouds as well as lightning and thunderstorms. So we're going with a 60% chance of KSC weather constraints being violated. And the SRB recovery area does look good. They're looking just 3 to 4 feet seas and winds light 8 to 12 knots. And the CONUS sites are looking good. The U.S. landing sites, no significant weather at Northrop or Edwards on launch day. And the TAL sites are looking good as well, the overseas landing sites. No significant weather there. If we do happen to delay 24 hours, we think there's even a better chance of getting thunderstorms. The winds from the west, the flow from the west is going to be a little bit stronger, giving us even a better chance of getting those thunderstorms closer to KSC. So we're going with a 70% chance of KSC weather prohibiting launch. And the 24-hour delay for the CONUS sites, we are concerned about showers at Edwards and also thunderstorms over the mountains at Northrop Field. But the TAL sites are looking good on this day. And if we do delay 48 hours, again, still concerned about thunderstorms, and again, it's a 70% chance of violating constraints at KSE. The CONUS sites, mainly concerned at Northrop, is still with those thunderstorms over the mountains. And the TAL sites are also concerned at both Maroon and Zaragoza with showers within 20 nautical miles. And this concludes my briefing.
Thank you, Kathy. We'll have questions now. Please identify yourself by name and affiliation and wait for the microphone.
Roger Gilmet for Space.com. For Glenn, with the somewhat pessimistic weather forecast for the next few days, what is the pad hold time for the science experiments? How long do you have before you have to start swapping out things?
Yeah, 3 of our science experiments have 24-hour hold capabilities, so if we scrub on day 1, we'll have to go in overnight and replace samples. So that's the tightest requirement we have right now, 24-hour hold.
Could that be, I'm sorry, could that be done overnight, or?
We have capability to do that replacement overnight.
Okay, thank you.
Dan Bill in the first row.
Yeah, 2 questions. Dan Billow, WESH-TV. And Glenn, could you tell us which experiments those are?
Those are the Serum, the commercial refrigerator incubation module for PCG, which is the protein crystal growth, the ZCG, zeolite crystal growth, and the BCSS, which is the biotechnology cell science storage.
And for Pete, Would you talk a little bit about what your monitoring protocol will be for the hydrogen vent line on the MLP during the countdown and the terminal countdown?
We do have a series of sensors to measure acoustics and vibration data, and we've got cameras poised to look at the vent line on the external side of the mobile launcher.
Would you tell me a little bit about the sensors? What do they do, and where are they?
I can't tell you the location. I do recall we had in the order of at least a half a dozen sensors, but I can't tell you their specific function.
Thanks.
Brad Liston, Reuters for Glenn. The glove box, is there anything going up on this mission to go in the glove box, or is that for future use?
They do have some sub-payloads, 4 sub-payloads that will be flying as part of the glove box. And they are the PFMI, the pore formation and mobility investigation, the SUBSA, which is the solidification using a baffle in sealed ampoules, in space, which is investigation the structure of paramagnetic aggregates from colloidal emulsions, and the SAMS, Space Acceleration Measurement System. Those are all sub-payloads of the MSG hardware. As far as material science, I think that's going to be used for future missions.
One more question in the middle.
Tracy Watson, USA Today for Kathy. When do you expect the thunderstorms to dwindle?
Not until after sunset. We don't expect them to dissipate until after sunset.
Which day?
Each day, actually. So.
Do we have any further questions here at KSC? We have no questions at any of the other NASA centers. That will conclude the briefing. Thank you.